Hi everyone, thanks for joining us at this live five. So here we are with Mackenzie Jackson. He's going to speak about hacking code. That's interesting. So source code as a vulnerability, how hackers exploit source code to attack organizations. About him, he's a developer advocate with a passion for code security. As a co founder and former CTO of a health tech startup, he learned firsthand how critical it is to build secure applications with robust developer operations. I totally agree on that. So today, as the developer advocate at Git Guardian, he is able to share his passion for code security with developers and work closely with research teams to show how malicious actors discover and exploit vulnerabilities in the code. So the stage is all yours, Mackenzie. Please
Awesome.
share your presentation and over to you.
Perfect. 1 second. Okay, great. Well, in here. So, yeah, I'm Mackenzie, and today I'm going to be talking a little bit about hacking codes, source code as a vulnerability. A lot of the times when we think about writing secure code, we're thinking about making sure our application in production is secure and free from exploitable vulnerabilities. But sometimes we don't actually realize that the source code itself, in and of itself, can be a security vulnerability. So I'm going to look a little bit of a different perspective. I'm going to go through here. We're going to talk first a little bit about source code and how it's a leaky asset, where you can find source code and how private source code can leak into different places. Then we'll talk about the different vulnerabilities that you can find within source code, in particular, that are active and passive threats within there. And then finally, of course, we'll talk a little bit about prevention of this. So, all right. So I think the first thing that we need to kind of really change our mindset of is that private code isn't really that private. And source code is a very leaky asset. So let's just take the simple example of Git repositories, because Git is by far the most popular version control software. Once a code enters into a Git repository, it is immediately distributed into multiple different systems and machines. So it's distributed onto the developer machines, probably onto their personal machines as well. And we also have no visibility of where it's ended up. We also have to think that everyone that has access to this code has access to everything within it, including the history, which I'll talk a little bit about. So it takes just one compromised account for someone to have access to these source code. And there's also a lot of very misconfigured Git repositories. Git repositories are often made public, not when their intention is to be public. Now, this can happen by accidentally pushing code to a public repository on, say, a cloud host like GitHub, or it can be to the misconfiguration of your internal Git repositories that are accidentally exposed to the public. But aside from Git, we can also expose our code in lots of different ways. It can be in our internal wiki, in our internal documentation. We can have it in our private messaging systems. So it's very common to share code through Slack messages, code that contains secrets, or sharing these credentials on these systems. So there's a lot of sensitive information in these places. We can also share and copy code from Q&A sites and examples. So there's lots and lots of different ways to do this. But we're also seeing that the source code is becoming really kind of a target for attackers. So we can see this in recent supply chain attacks. So you probably have all heard that CodeCov had a recent supply chain attack. They were part of that, where people were able to get access to credentials, including Git tokens. But we also see things like the EA Games had just had all their source code leaked for FIFA. And this isn't a problem that's contained just to purely software companies. The UN, I covered the UN data breach, which all stemmed from these Git repositories being made public and having misconfigured Git repositories. So source code can expose itself in lots of different ways, and we need to be really wary of that, particularly when we talk a little bit more about the type of sensitive information that we can find within our source code. So I'm going to take a little bit of time just to talk about some of the problems of this with Git in particular, because Git is so widely used. It's probably the most relevant system to talk about here. So Git's repositories are not vaults. We can sometimes treat them like this. We store our API keys in here. We have our environment variables. And I can understand why we do this, because it's convenient to store these secrets in a central Git repository because it's so easy to distribute them. It means that we can rotate them. But Git is really not designed to kind of handle this really sensitive information. But the reality is that really it's the current state of the world. We also need to look at Git history, because the Git history lives on forever. Now, of course, you can say that you can squash a history or that you could rewrite your history. But the reality is that the reason why we use version control is so that we have access to all of that history. So we don't really want to change this, but it can create a problem. Because if we're looking at vulnerabilities in applications, so some of the OWASP top 10, if we look at injection or cross-site scripting, that vulnerability appears in the latest version of the application. So if we update our app and we remove cross-site scripting vulnerability, then we no longer have to worry about that. It doesn't matter that it's in the previous version. But when it comes to source code as the vulnerability, we actually have to worry about all of the history that we have here. Are there secrets exposed within the history? Do we have sensitive files and PII that we've removed in our Git history? So we need to be aware that the history never dies. And this can create a new problem, particularly in finding the vulnerabilities. So let's use a really simple example. Here we have a Git tree where we just have a main branch and a developer branch. So let's say that we're working on a new feature and we really just want to get this feature working quickly. So we hard code in some secrets. We kind of save our access and debug logs because we want to go back and find these. We mix in some data in there because we're just working on getting it to the first stage, getting it functional. And we'll go back and tidy it up later, right? So we do this. We get this all ready. We remove everything that shouldn't be there. We put our hard-coded secrets as environment variables, and everything's looking really nice for our code review. So when our code review comes up, what actually happens is the reviewer looks at the latest version on your development branch and the latest version in the main branch. He compares the two and then pulls it in. But he or she is completely unaware of all of the sensitive information that was actually committed back in the history and didn't get access to it. So this is where Git can become a problem, particularly if we look on screen at this kind of typical graph of Git history. We can see that we really create as much code as we delete. When you look at any additions and deletions graph on GitHub, it almost looks exactly the same. It's like a rule of nature that I'm not sure why this is true, but it is true. We seem to never kind of add a bunch of code without removing some first. So it means that the actual source code that we have is a lot deeper. We've committed on top of it a lot of times. And this is difficult because it means it's really hard for us as developers to even know what's in our Git history. But if you're a malicious actor and you're looking for vulnerabilities, then you know that this is a sweet spot that can contain a trove of information. Now, the other areas is that when we're talking about Git or GitHub in particular, the way that we use our accounts is unique. And that is that I have a personal GitHub account, but I use it for both my personal public repositories and my professional use. And I have all my credentials saved onto my machine, which means that it's really easy for me to accidentally push code that's meant to be private into a public repository. And we see this happening with alarming regularity. In fact, I've even done it myself by accident. So we have to really kind of consider this. And then the last point before I move on is when we think about public Git repositories, particularly in cloud hosts like GitHub, we intellectually know that if we have something that's public, then anyone can view it. You can go to the URL or you can search for it and it will come up. But what we don't often understand is that it's not just public, it's actually broadcast. You see, GitHub has a public API. Every commit that's made that's public every time a repository is made open source, it's broadcast in the public GitHub API. And this means that while I don't need to find your repository and search through it, I can just monitor that steady flow of information. So this is why it's really concerning that, one, we have to make sure that we don't have anything in private Git repositories, but two, when we do open source something or when we accidentally make a mistake, we can release a whole bunch of history that contains a lot of sensitive information. So another area is that Git has really become a target. And I mentioned briefly before the CodeCov attack. So I want to talk a little bit about kind of the trends that we're seeing, and I'll use CodeCov as an example for this. So CodeCov is a code coverage tool, and many people had it in their CI pipelines. And attackers were able to enter in a backdoor basically into a bash uploader script. And what this did was it took the environment variables from your CI environment and sent them to the attackers. And what's scary about that is included in those environment variables is your private Git access tokens. And we can see that the private Git repositories were actually the target for the attackers in this case. And we know this based on the disclosures that other companies made. So for example, one attack path was the attackers compromised, got access keys to Twilio's private Git repositories. They then used those keys to access the private repositories and scan those for vulnerabilities, in which they found quite a few. And Twilio then disclosed this, but we also saw this in a number of different companies, including Rapid7, who had their source code released through the CodeCov attack. So the whole point of this is that when we're talking about Git in particular, even if we're talking about private source code, we have to stop thinking about it like it's in some kind of vault and it's never going to get out. Source code is very leaky, particularly on Git, and we have no real visibility over where it ends up, and it can easily be compromised. But it's not just that. Now, I know that Steve from Sneak talked about the use of like libraries and components and dependencies within applications, and I'm sure we'll hear more about this today, so I won't talk much about it. But most of the code that you actually use is not your own code. It's from libraries, it's on your dependencies. And what this means is that hackers actually know your code better than you know it yourself, because they know all the vulnerabilities within these dependencies. And dependencies can have dependencies with dependencies that have vulnerabilities that can be used to exploit your application. And these dependencies are very apparent in your source code. Now, of course, there's other ways to find dependencies that your application is using, but if an attacker has their source code, well, then this is the holy grail to be able to find all the inner workings of your application and find all the vulnerable dependencies that it's running. And it's as simple as going to the disclosed vulnerabilities, the publicly disclosed vulnerabilities, and even downloading some exploits in some case and running them to be able to compromise your application. So we also have to think about this. And then the last place I'll talk about in terms of exposing your private source code inadvertently is using the example of a lot of these Q&A sites, right? I love Stack Overflow. It's one of my favorite places to hang out, and every time I get stuck, it's one of my first point of calls. But we have to be careful about what we publish in here. So let me give you an example. This is an example I found recently where a user was searching for encryption and decryption in a Java project and is having some troubles. So luckily, someone replied with a great answer. It was upvoted a lot when there was a lot of people commenting saying thank you and that they're also using this. The problem was that the code that the guy answered with worked, but was really insecure. In fact, it was one of the worst ways I think you can kind of do encryption in Java in production. And with just a little couple of clicks, we can go to the original posters and see his profile, see what company he works for, access to all his social media and his repositories. So if I wanted to run an attack on a company that this software engineer worked for, well, I can now see vulnerable code that probably is in that application. It's a good place for me to start an exploit. So we also have to be careful about what we're copying into our applications and what we're posting out, because unfortunately, malicious users are monitoring these places. And there's an example of a malicious hacker on Stack Overflow that inserted Bitcoin cryptocurrency mining algorithm into some of his JavaScript answers, which ran locally in the browser. So every time you visited someone's website with this code snippet, you were mining cryptocurrency for this attacker. So we have to be careful about things like that. Okay, so we've talked about how code can be sprawled and how we can accidentally leak our private code or give hints as to what's inside there. Let's talk about the threats that are inside our source code. Now, I don't want to talk so much about vulnerabilities that appear in applications. So we've talked about injection and cross-site scripting, and these things are really threats from your application when it's running. What I want to talk about is threats that are within your source code. So the first area we have here is active threats. So these are things like hard-coded secrets, where simply by having someone access your code, you already have had a breach. We can also see this in logs, like error logs and debugs logs. These can give out a whole bunch of information and are really common to find inside our private source code repositories. Environment variables, we have an example of environment variable here, which often contain important information about what kind of systems you're running, can contain credentials. I can see a lot of developer comments that contain sensitive information. In fact, as one of my favorite first steps, if I can get access to source code, if I'm trying to run an exploit, is to look for developer comments that say, delete in prod. Because they often are not deleted in prod or are within the Git history. And then I can find often a secret or some information about the file structure or endpoints or business logic that exposes itself in code. So we have to be careful about our developer comments and what we're actually putting in there. And then finally, we can talk about personal identifiable information. I see a huge amount of MySQL dumps and databases, XML files that contain personal information that is inside our Git repositories. We want to make sure that all this personal information is kept separate. We don't want to mix it in with our code. And we're seeing more and more that Git repositories are starting to be used like Dropbox accounts, where they can contain lots of personal information on them pertaining to your organization, your customers, or even yourself. One example was I covered a breach that happened in the Indian government, and one of the systems that was breached was the police departments. Particular police departments in India, and they had exposed Git repositories within them. Within these exposed Git repositories were police reports. So they had misconfigured Git repositories with source code for their internal systems, and they also were storing police reports within these. And these police reports obviously contained a huge amount of personal information and photos and things that police departments, you really don't want to get out. So this is a bit of a far left example, but you get the idea that the stuff that's in our code, source code, our code base, can be really quite vulnerable. So we need to be careful of that. Now, the other area that we can talk about is our passive threats. So passive threats are things that, okay, so they don't present a threat by someone just having your source code, but they're significant enough that they're going to lead the attacker to vulnerabilities within your application. Now, you can find vulnerabilities within that source code that we've talked about, but really I'm talking about things that are very difficult to find from attacking your application. So cryptography weaknesses, are you using weak random values? This is a great place where I want to start to try and find weaknesses in an application if I have access to the source code. Are you using insecure hashing methods on your passwords? Because if you're using variable ways and it's reversible, well, then I can gain access to personal information that I want. I'm looking for business and application logic. How are you kind of handling events? Can I find anything within there that I can exploit? The silly example is if you have a banking application that can send $50, what happens if you send negative $50? Now, this is kind of silly, and we talk a lot about this in security with shopping carts and negative items, but I'm looking for these types of things within the source code that may be difficult for me to attack in a running application. I'm also looking for things like exposed endpoints and file structures, ways that I want to get a great map of the application, kind of get the inside knowledge so I know which targets to attack. and insecure object references. How are you handling your assets? How are you handling unique universal identifiers? Are there patterns in there that I can exploit? And then finally, do you have missing access controls? Missing access controls is something that is really quite easy to find in source code if you know what you're looking for and you can work through the structure, but it can be difficult in a running application through automated testing. So these are the kind of threats that we need to look out for in our source code. And these active threats, the hard-coded secrets, personal identifiable information, we really want to make sure that these aren't inside our source code, because not only can attackers find it, it can be huge compliance issues and come with fines if you're working in large companies. So when we look at these threats that we just talked about, and a great resource is the OWASP Code Review Guide. And it's a 200-page code review guide that's way more interesting than it actually sounds. I know it sounds really boring, but it's got some great stuff in there. Check it out. It's a good document. But within here, one thing that I found particularly interesting was that they did a survey about the type of vulnerabilities that were discovered. This is the OWASP top 10, and where they were discovered. Now, this experiment was done when the OWASP top 10 was slightly different, so it doesn't correlate directly to the top 10 now. But what we can see is that in yellow and blue, we can see the vulnerabilities that were found with automated testing, either through code scanning or automated scanning from that. So these are where using static analyzing tools are fantastic, or dynamic application security testing tools. So these are the type of vulnerabilities that we're really looking for within our application using automated tools. But we can also see a lot of stuff that isn't picked up at all, or very uncommonly picked up through these automated tools. So sensitive data exposure, we've talked about this, missing access control, insecure direct object referencing. These are the things that we really need to look at in our code reviews. And as an attacker, these are the things that I'm really trying to find, because these have the highest probability that they've been missed by automated tools. So yeah, check out that code review guide. Now, the other area is secrets. We talked a little bit about sensitive data and secrets. Well, this is actually a huge problem. So I work for GitGuardian, and last year we decided to conduct a massive research project that analyzed how big of an issue is secrets inside public Git repositories. So we scanned every single Git commit that happened in 2020. So remember at the start, I said that GitHub has a public API when you can monitor all the public events. Well, that's exactly what we did. And we found over 2 million secrets throughout that year, nearly 5,000 a day. And we were able to verify most of these automatically against providers to ensure that they were actually true positives. So this is a huge amount of information. And remember, we're talking about public Git repositories. The problem is so much more significant when we include private Git repositories. And this is why attackers are really kind of targeting these code source for these active threats, these active vulnerabilities. So what we found is that 85% of leaks happen on personal GitHub repositories, and 15% happen on organizations' repositories. But what's really interesting is that when you look at the secrets that are leaked on organizations, so for example, an AWS key that belonged to an organization, they were leaked 80% of the time on an employee's personal GitHub repository. So it goes to show that mistakes like pushing code into the wrong repositories, copying code, or accidentally releasing private source code happens a lot. And this is one example of secrets to show the scale of it. But when we add in personal identifiable information and the other areas of active threats and source code, wow, there becomes a huge problem. So what's the solution, and what should we be aiming for? The question that we should all be aiming to say yes to is, can we open source our software tomorrow? Now, I'm not talking about this from a proprietary point of view where, as an organization, we still will want to keep our source code private, of course. I'm more talking about it from a security point of view. Are there active threats in our source code, or passive threats that are going to guide hackers to our vulnerabilities within our source code that would be exploited if we made our repositories public tomorrow? And can we sleep well if we do that? That's the goal. It's a very hard thing to achieve because of really how we develop software today. But this should be the gold standard of what we're trying to achieve. And when we're writing code as developers, this should be in the back of your head, because remember that your Git history lasts forever. So are you contributing something that would create a vulnerability in the future? So how do we prevent all this, and how do we actually get to that level? Well, there's this great thing called DevSecOps or shift left. And really what it means is, let's get the developers, people like me, people like you, into the loop early on. So it happens through awareness and training, and really understanding that our source code can be a vulnerability, and not relying on security teams to pick up active threats just in the application, or the ops teams to run automated scanning checks on the latest version. Developers need to be part of this process as well, and really look at the source code that we're writing, that we're committing, and making sure that even in our development branches and our playgrounds, as I sometimes call them, that we're not releasing any information that an attacker could use against us. So the tools, how do we do this? So the number one tool that we have at our disposal is code reviews. But code reviews, we need to also understand the security risks. So I've already mentioned the OAuth's code review guide. This is a fantastic guide if you want to know what security risks to look out for in code reviews, what can be picked up by automated testing tools, and what as humans we really should be looking for. So this is one of the number one steps into looking at making sure that your source code doesn't become a vulnerability in and of itself. And we also need to create awareness around this problem. So props to OAuth, as always, for organizing these awesome events and Developer Awareness Summit. These are the exact type of events that we need to encourage and promote to be able to get everyone on board that security needs to be done throughout the entire software development lifecycle, and not just focusing on our applications. And then, of course, there are tools that we can use to help this. The number one tool in my tool belt for secure code is secrets detection. So we talked a lot about API keys and database credentials, these types of things. We need to make sure that we have secrets detection in our software development lifecycle, and not just on the latest version. We need to make sure that we have no secrets throughout our entire Git history, because this is the number one active threat that we see in source code that makes it a vulnerability. We also need to have repository monitoring. So we need to identify misconfigurations in our Git. We need to know when personal identifiable information is committed in there, ban files like env and XML spreadsheets that can often contain sensitive information. So this is another tool that we really should be implementing to make sure that our source code stays the same. Now, then we have some other tools. So dependency scanning, static application security testing. These are designed more to secure our application, but by implementing them, we can also secure our source code from these tools. And then also for securing applications, there's a lot of different things that we can do. Out of the scope for this talk, but definitely check out. For all tools, I always recommend the OAuth. The OAuth has great resources for be able to find open source tools that are available in each of these categories. Secrets detection, no surprise that I'm from GitGuardian, so obviously I'd recommend GitGuardian from that. It's a commercial tool. It is free for devs. But if you don't trust commercial tools, there's open source versions for secrets detection as well. So Git leaks, Trufflehog are open source. They're on GitHub repositories. And they implement some regex pattern searching for secrets inside your source code. Dependency scanning. So I didn't know Snyk was the platinum sponsor, but obviously they're number one in my book for this type of for dependency scanning. Also some other ones in there too. And again, OAuth has some great resources for checking dependencies. And the same with static application security testing. Don't need to go into it too much, because the gold standards for all of these resources, if you want to find out more, is diving into these sections in the OS website. Okay, so that's it from me. Just as a kind of quick rundown, to take away from this talk, remember that code is a very leaky asset, and we have limited visibility over where it ends up sprawling. Git's not a vault. It's not an appropriate place to store sensitive information, and that our history always lives on. So source code can be a vulnerability in and of itself, so we need to protect it as if it was such an asset. Developers need to share responsibilities, and also we need to use tools in conjunction with code reviews, training and awareness to make sure that we can maintain security in our source code. So thanks so much for having me, guys. I'm really enjoying the OAuth Summit myself. So I hope that you guys continue on and enjoy the talks, and I'll be happy to answer any questions on Twitter or anywhere else.
Thank you so much, Mackenzie. It was a wonderful session, and there are a few questions in the chat box. You can answer there, and actually, yeah, you can go ahead and answer it there, and we will see everyone after a quick break.
Awesome. Thanks.
Yeah.
See you guys.
Yeah, thank you so much. And before we go, I would like to thank our sponsors for sponsoring the event. Thank you so much, Sneak, for sponsoring this event.